simplified form for radicals involves finding radical expressions that don't have perfect cubes as factors of what's under a cube root or perfect squares as a factor of what's under square roots. In other words, we want to get everything we can out from under the radical. We don't want any fractions under the radical, and we don't want any radicals in the denominator. Let's look at some problems that involve writing radical expressions in simplified form. I've written down simplify, and the first one is simply the square root of 48. Now this is a square root, and I have a perfect square that's a factor of 48. That perfect square is 16. I can write 48 as 16 times 3. So I use my first property of radicals to separate this into two separate radicals, square root 16 times square root 3. And now I know the square root of 16 is 4 times square root 3. So 4 square root 3 is the simplified form of square root 48. So what I look for under square roots are perfect square factors. If this was a cube root, I'd look for perfect cube factors. I want to get as much out from under this radical as I can. Then I consider this to be simplified form for this radical expression. Here's our next problem. Let's simplify cube root 40 x to the 4th y to the 7th. And we're going to assume again that these variables represent positive numbers. Okay, I'm looking for the largest perfect cube that divides 40. That will be 8. 8 times 5 is 40. Now, the largest perfect cube that divides x to the 4th, x cubed. The largest perfect cube that divides y to the 7th, y cubed. Now, that will be times 5, x, y to the, let's see, y to the 7th. I'm going to put down here. The largest perfect cube that divides y to the 7th is y to the 6th. So 8 times 5 is 40, x cubed times x is x to the 4th, and y to the 6th times y is going to be y to the 7th. Now, I'll separate this into two separate radicals and then take my cube root of each one. The cube root of 8x cubed y to the 6th is going to be 2x y squared, because this is the expression I cubed to get this right here. This 5xy is still under that cube root. So this is the simplified form of this radical expression right here, and I put it in simplified form by removing the greatest, the largest perfect cube that's a factor of this radicand right here. And that largest perfect cube turns out to be 8x cubed y to the 6th. I looked for cubes because I'm working with a cube root. Here's another problem. Let's put square root 1/5 into simplified form. It's not in simplified form because we have a fraction under a radical. So I'll separate this into two separate radicals, square root 1 over square root 5, using property 2 for radicals. Now that's going to be square root of 1, which is 1, over square root 5. Now this is not in simplified form because I have a square root in the denominator. To get rid of that, I'll do what's called rationalizing the denominator by multiplying the whole fraction by the number 1 in the form square root 5 over square root 5. In the numerator, I get square root 5. In the denominator, I get square root 25, which is just 5. Now, this expression is in simplified form because there's no perfect square that's a factor of 5, so I can't get any more out from under the radical. There's no fractions under this square root, and there's no square roots in the denominator. So a radical expression that satisfies those three criteria is said to be in simplified form for radicals. Let's look at one last problem. Square root of 75x cubed y squared, all divided by 2z. First thing I'm going to do is separate the numerator and denominator into two separate radicals. As I do that, I'm going to look for the largest perfect square that divides this numerator, which will be 25x squared y squared, and that will be times 3x. So 3 times 25 is 75, x times x squared is x cubed, and then I have my y squared right there. That's all divided by square root of 2z. Now, this will be equal to, when I take this square root separately, 5xy square root 3x, all divided by square root 2z. Now I want to check this and see if it's in simplified form. There's no perfect squares that divide this or this, so I've gotten everything I can out from under the radicals. There's no fractions underneath each one of these, but I do have a radical in the denominator, so I need to get rid of that. Then the expression that's left after I do that will be in simplified form. So I rationalize the denominator by multiplying numerator and denominator by square root 2z. In the numerator, I have 5xy square root of square root 3x times square root 2z will be square root 6xz. In the denominator, square root 2z times square root 2z will be simply 2z. And this is the expression that's in simplified form. So this is the simplified form version of this original radical expression. And that's a look at some of the kind of problems that involve putting a radical expression into simplified form.